Hi, I'm Bob Vila. Welcome home again to our Vermont farmhouse project here in the Quechee area. Today, as you can see, we're putting the finishing touches on our roofing system. We're also going to be taking you down to NASA in Houston, Texas, where we'll get an idea of the ultimate connected home, a mock-up of the space station. And right here, we'll be installing some of the structured wiring to make this a connected home. Stick around. It's good to have you home again. As forecast, the rains are arriving, and so we've thrown up a big green tarp over the portions of the roof on the main house that have already been sheathed in OSB. We don't want it to get soaked. But right now we're dealing with the shed roof portion over the kitchen and family room, and this is essentially, I think it's a 4-pitched roof. It's a shed roof that at the corner ends in a hip, so it's a little bit complicated. And let's take a closer look at how we cut it. Once the shed roof gets to the hip portion, you got a hip rafter that determines all the lengths of the different final rafters. And so that's what our lead framing carpenter, Dan Enright, is doing right here.
Make it 3/4, please.
Dan, how do you determine the angle that you have to make the cut at so that it is pitched at a 4?
Well, what we have here, it's a wraparound porch with a 4/12 pitch on it.
Right.
Comes into the hip that wraps around the corner.
Right.
So we know that the top cut is a 4/12 on a 45 degree to tie into the hip.
Right, and so you use your square.
So with the square, it's all laid out right here on these speed squares. This is your 4/12 top cut. It's a 4/12 right there. It's already all predetermined. It's not like the old framing squares.
Exactly, so you just use that
Just
to
like that. That's
make
a
the mark.
4/12 top cut. We know
Okay.
that's our long of a 45 degree because it's tying into the hip roof at a 45 degree.
And then each one is a separate length because they're progressing.
Right. As it progresses down the hip.
Okay. All right, down at the other end, we've got to make a cut that's called a bird's mouth. It basically is where it sets on the outside wall. And Dan, how do you go about figuring that one?
Well, what we do is we have a measurement from a long point of where it's going to hit the hip to the inside of the wall, which would be this point right here.
Yeah.
Which is the level cut of a 4/12, like so.
So here we have a 4/12.
So here we have a 4/12, and we know that we want 6 inches of seat cut, because that's the width of the wall with the plywood.
Right.
6 inches there, squared down off of that.
Right.
So that gives us our bird's mouth right there, which we made a pattern here, because we have a number of rafters to cut. And this is a pattern that we use. It's all on there, so you don't have to use a square every time. You just set your pattern down.
Exactly. And this is where the outside wall meets the rafter. Great.
Right.
Now, when you're framing a hip, you have to very often make sure that you're not bowing out the hip rafter by putting too many of the rafters up against it. And so here we're countering the first one on one side with the first one on the other side. Now you can see how the angle cut on the rafter fits against the hip, and the bird's mouth cut rests on the sill plate. Okay, and that's the last of the rafters. We'll have to put some OSB sheathing on it. Before you know it, we'll have a roof over our heads. When we come back, we'll talk about structured wiring and the connected home. Stick around. Well, we've completed the rough-in for the staircase leading down into the basement, and behind me through the partitions here you can see we've got the concrete precast stairs that come in through the bulkhead. Now that room over there is the mechanical area, but the rest of the basement is really unfinished space. And boy, wouldn't this be great, you know, hobby space and storage space, maybe even a wine cellar in here. But let's say hi to Tim Woods from the Internet Home Alliance.
Hi, Bob.
How are you, Tim?
Good, how are you?
Great. Hey, Tim, what is the Internet Home Alliance?
Well, the Internet Home Alliance is a strong association of companies. I'm from Sunberg Farrar. The founding members are Cisco, Sears, Panasonic, Invencis, General Motors, and Home Director.
Yeah.
All of them got together and committed to bringing the internet lifestyle to the consumer.
Okay. And so in this house here in Quechee, Vermont,
yes,
we're going to try to make the internet lifestyle available to whoever ends up buying this
We're
house.
going to bring it to life. That's
and
right.
how is that going to work?
Well, one of the things we're starting off with is structured wiring.
But there's a satellite dish involved, right? Because
yes,
we're in outer space here in Vermont.
That's right. That's absolutely right. One of the unique things about the Quechee site versus any other site is that this site, you can't get DSL, you can't get broadband services, you can't get those kind of high data rate transmissions.
Right.
So we had to go with two-way satellite communication from Hughes Corporation.
Okay.
It's called Direct Duo, and it allows that two-way communication via the satellite.
But then the cabling itself is, what have I got here?
Well, that's a 2+2. It's basically Cat5 and it's RJ. And people would kind of look at that as Ethernet and cable.
Right.
People are pretty familiar with those two things. And this is what it ends up coming out looking like. You've got your cable system right here.
We've all seen that.
Two cable pairs, right? And then you've got your Ethernet cables.
Right.
And what we're doing is we pulled all those lines down from the different rooms in the house. You see them labeled. We've got guest room, dining room, kitchen, right?
So every room in the house will have capabilities.
Pretty much every room. And what it comes out for the consumer, it looks like this. And what consumers are really used to is seeing this in their homes. What we're talking about is adding this dimension, where you have the ability and the flexibility to put computers and audiovisual equipment and all those wonderful things that are coming with the internet lifestyle into every single room.
Okay, and there's two cable connections?
You've got two cable connections. We have two Cat5 connections in here. And this allows us to do things like streaming video. We're going to have high definition TV. All of these types of things are allowable because we have this universal port in the house.
Now, somebody made a big deal about not being able to let you guys install this until after the electrical was already in. Why is that?
Well, absolutely. There's interference caused between the electrical system, standard electrical system, and structured wiring.
Okay.
There's a kind of a hum that's created by your electrical system, and you need to be a certain distance apart.
So you don't want to cross the wires or keep them too close together?
No, not at all. That would not be good.
Avoid the buzzes.
Right.
Now, there's a plan up on the wall here that explains what's going on in all the different rooms. So, for example, what are all the red boxes?
Well, all the red boxes are security. We've got an ADT security system coming in here. We've got audio visual. You see up here in the master bedroom and in the great room, we've got our AV system. That's going to support our Panasonic.
So we
AV
can
equipment.
control from a central location. Let's say we had a 300 CD player. We can control in every room what we want to listen to,
right?
Whether we want it loud or low, or
absolutely. You've got
a lot of treble, whatever.
A flexibility. You can do your different music in every room if you want to. You have these great control panels that are going to be on the wall. But what's even better is we've got this Qubit web tablet. It's wireless. You'll be able to carry it around the house with you, and you'll be able to control audio-visual, security, all of those things.
Fabulous. Can you shop with it?
You know what? You probably will.
Thanks a lot, Tim.
Thank you, Bob.
All right. Next, we'll see the ultimate connected home, a mock-up of the International Space Station in Houston, Texas. Another space shuttle mission blasts off, taking its crew of astronauts to a very unique construction site, the International Space Station. The space station under construction functions as a working laboratory and a residence for the astronauts. It's the ultimate connected home. We visited a mock-up of the space station at the NASA Training Center in Houston, Texas, to find out more. We're looking at the outside of the mock-up now, and with me is Mike Hawes, who's the director of the NASA Space Station program. Mike, let's talk a minute about how this is all connected, because this is all very smart stuff.
You're talking about the ultimate smart house, Bob. You have to pre-plan everything that you're going to do, but you have to route all of your electrical power, your communications, fluid lines if you have anything, all have to be routed and pre-planned. We're looking at the outside of the hatch to one of the space station elements, and we have to make sure that all around this hatch that we've already plumbed and set in all of these different types of connectors that we're going to use to establish your power and your data connections for the space station.
And it's all reporting to a brain someplace, right?
It's all reporting to a lot of brains. There are computers all over the space station that connect to different parts of the space station, collect the information, and then they integrate that all so it's sent to the ground.
So that it can tell a laptop or a small portable computer if there's a problem someplace anywhere
Absolutely.
on the craft?
Absolutely. It reports into the central computers, and the crew actually uses laptops to access all that information to know what the problem is. Same time, the ground team is looking at the same data, trying to understand what's going on as well.
Now let's go inside one of the space station modules and see what it's like to live and work in outer space. Astronaut Jeff Weissoff recently was on the 100th space shuttle flight up to the space station, right?
That's correct.
And here we are in a mock-up of the first part of it that went up there, the Russian part?
This is the U.S.
This is the
module.
US part.
Yeah, the node. It's also called Unity.
Unity, okay. And Unity will have an additional number of modules attached to it. I know that's coming down the line. Recently, a whole series of photovoltaic arrays was placed on the station.
That's right. We put the pedestal on which the solar arrays went on top of, and then the crew after us put the solar arrays on, and they would actually be attached to the attach point that's above our heads. Each of these doors hides an attach point where we're going to put a future module.
This is a high-fidelity mock-up, and that means that it is very, very true to the actual thing in outer space.
That's right.
Except for one key, there's weight here.
That's right.
Out there you've got weightlessness. That's why we're walking on plexiglass here, but in fact out there you'd be floating around in this space, and it's so symmetrical because it seems like there's a hatch there, one above me and one to either side of me, one that we came in, one behind. So this is really the geometry of how this will be all assembled.
That's right, and it's very deceiving here where you feel like you have a floor and a ceiling in space. When you're floating in here, because it's very symmetric, you can orient yourself in any position and feel like that's the floor. And we have foot restraints that are attached in various locations here that allow you to put your feet in and actually do work from those foot restraints.
So you get your feet in there and you'd be upside down. It sounds like that's the fun of it.
That's part of the fun of it.
Yeah.
That's a really interesting feeling.
Yeah. Now, when you're going into outer space, do you go through one of these hatches as well?
Well, for the near-term flights, we've been using the airlock that's in the shuttle. That's how you get outside. But in the future, we're going to attach this module to the space station. This is called the airlock. And when you come inside here, you'll see it's a pretty spacious area where you can get your spacesuit on. And once you're dressed in your spacesuit, you attach an umbilical to it, which supplies you with oxygen and water and cooling while you're getting ready to go outside. And this hatch closes and allows you to decompress this volume and then go outside using the far hatch over there.
So that everything is really interconnected.
That's correct.
And anything that's going on in here is going to be recorded someplace else, right?
That's right.
How about the color schemes? I noticed there's a very interesting blue and a very interesting green on the sides here.
We've tried to give each module its own look so that you always know where you are. If you had some reason like the lights went out or the modules were filled with smoke and you had to try to find your way to the crew escape vehicle, we'd like you to always know what module you're in, and so the color schemes help us with that.
Sure, makes sense. Now, the next kind of module that's being taken up there will be your science lab, right?
That's correct. That's coming up in first of next year.
And what's this one called?
This is called Destiny. It's the U.S. laboratory where much of the science will take place.
And so this again is a mock-up where they try to have high fidelity in terms of what will actually be in outer space.
That's correct.
And what, for example, what would be happening here?
Well, this is one of the experiment racks, and this particular rack was designed to give companies a chance to fly small payloads in rapid succession. What we do is we put experiments in small boxes like this, and we can supply from the connections up here. You can see locker 1, locker 2, locker 3. We can supply them power and data and water cooling so that they can run their experiment. The box can then be taken out, brought back home, and a new box can be put in, and that allows us to turn over experiments rapidly and help address particularly small startup companies and things of that sort that want to fly their experiments and get their results more quickly back to the ground. This is called an express rack for that reason.
Sure. So each one of these could be a small experiment, say for a biotech company that needs to have the actual scientific experiment occur in a weightless outer space situation.
That's correct.
Each one is connected to databases, et cetera, so that you're supplying and taking all the information. What kind of actual experiments, what kind of projects are we looking at here?
Well, one of the things we're very interested in is finding out what happens to the human body so that we can eventually send people to Mars. And we know from our experience in our joint program on Mir with the Russians, and we'll find out from the crew that's currently on board when they return that the human body degrades a little bit, and it's been in space for a long time. Your bones get softer, you lose calcium in the bones, just like osteoporosis in elderly on the ground. And so we need to find a way to prevent that from happening, so when people arrive at Mars after a 5-month, 6-month, maybe year-long journey, that they'll be able to do useful work once they get to Mars. And so those are the kinds of things we want to learn and figure out how to get medicines that might get around those kinds of problems.
That can also help the elderly back on.
That's correct.
On Earth. Now, what about the exterior of the space station? If you need to do things to the outside, do you always have to go outside, or can you work from in here?
Actually, we can work from in here. This is a robotic station, so we basically have an external construction worker that's a robot, and you can control it and translate it using this hand controller here, or you can rotate it and pitch it and yaw it using this hand controller here. And that allows you to do work while you're outside, and you can see your work using these 3 screens.
It's fascinating. I'm almost tempted to go up there. Thanks. Next, we'll be working on the garage roof truss system at our Vermont country retreat. Ted Riley's our construction supervisor here at Quechee, and are we a little bit behind?
Yes, we are, Bob. Approximately 2 weeks from the original schedule because of the mud season.
And how does the mud season affect us?
They actually post roads, and you have to get permission on a daily basis in order to bring cement trucks and heavy equipment over the roads.
And so some of the times the roads are just not passable, and you can't get a concrete
Yes, that is right.
Or you can't get a lumber load. But we have made progress since last week when we were putting down our sill plates here. We've got all our partitions in place, and everything is spring braced. And what is that big 2x12 doing up there?
That is a temporary 2x12 that Dan put up there to hold the trusses. The boom truck will put up the trusses.
Now, Ted, the rest of the house is stick built. All the roof systems are just rafters. How come we switched over to trusses here for the garage roof?
Because we're able to put a room and attic truss together, which actually gives us a bonus room right here.
So that this area that we're looking at in the middle here will be like a storage loft in the above the garage?
Storage loft, could be a home office if one chose to make it that way.
Huh. So what we've done is basically ordered them custom for this size of...
For this size garage.
And where are they made?
In Canada, Bob.
Now, is there a cost savings to doing it stick built?
There's really not much cost savings, except for it allows you to span a great distance, so we don't have any structure underneath to bother the garage.
We got a free span in the garage.
Right.
So the boom is a real help in getting the load up to the work area. And now the framers can just slide them over into place.
Ready? Yeah. Go.
So they'll be spaced 24 inches apart, right, Ted?
Yes, they are. 24-inch on center.
And of course, it looks like we've got a funny flat-topped French roof, but they make the trusses in 2 pieces. And this will be added later. This is the basic peak of the gable. Why do they do that?
Because of hauling over the roads, they have certain requirements.
Yeah. You see these going down the road, they're upside down.
Yes, sir.
And if you had that on there, it'd be dragging through
Dragging
the
in
pavement.
the asphalt.
Right. Okay, let's watch him get another one up. All right, tack another one in place, put the spacers on temporarily so they're stiff, and give them an hour, they'll have the roof system in place. But we're out of time. Come home again next week when we'll be working on the roofing, insulation, and drywall. Also, we'll make another visit to the Cobb Hill co-housing community in Heartland, Vermont. Till then, I'm Bob Vila. It's good to have you home again. For lots of information and resources for your home improvement project, check out my website at bobvila.com.